quadratic function can be graphed as a parabola. After solving for one of the many forms of the quadratic equation, either standard, vertex, or factored form, you can graph the function. By solving, you can find points on the graph, vertex, axis of symmetry, or intercepts. And with these, they can be used to solve many different real-life problems, as you will see.
In this real life scenario, you and a friend are bored in a building that you live in, so you decide to throw a ball out the window as high as you can. So from your first floor room, you throw your ball as high as you can, it goes up, and the ball comes down. To set up this problem, first we want to graph. We want to set up the y-axis, which is where the ball starts from, and the x-axis, which is where the ball lands. Next, we want to introduce the equation that we are using to solve, which is h of t equals negative 16t squared plus 112t plus 40. T stands for time, h of t stands for height of time. So in this scenario, you and your friend want to find out when the ball reaches 200 feet. So you want to find out when the ball reaches 200 feet, which is not drawn to scale, but is right here, 200 feet. So using this equation, you want to plug in 200 as your height, which is what you're solving for. So 200 equals negative 16t squared plus 112t plus 40. Next, you want to solve for this. Okay, to solve, for the first step, you want to get everything onto the right side of the equation. So you start by subtracting 200 from each side. So you get 0 equals negative 16t squared plus 112t minus 160. Next, you want to factor out this equation. You want to solve by factoring. So first you can factor out the negative 16. And then you want to continue factoring. You want to find two numbers that multiply together to get positive 10, and add to get negative 7, which is negative 2 and negative 5. Then you want to find the zeros of these two numbers. Equal them both to 0, and you get 2 and 5. So your two answers that you get are t equals 2 and t equals 5. Both of these answers are going to be used for this question, because you can find that at second 2, the ball reaches 200 feet. It comes up and then comes back down. Again at second number 5, it reaches 200 feet. To put the solution into more of a formal graph, it is drawn to scale. So we have 200 on the y, which would be the feet, and the seconds, which would be seconds 2 and seconds 5. So we want to graph this as a parabola. So it would start, the ball comes up, it comes back down, intersects, and that would be a more precise ball path, showing the intersection at 2 seconds and at 5 seconds.
The second problem we'll be working through will be using quadratic functions, but instead of the standard form of the quadratic equation, we'll be using the vertex form. So this problem is involving the rocket. A rocket is launched off a platform. The height of the platform is shown using the equation h of x equals negative 5 parenthesis x minus 4 squared plus 180. So the first question we are trying to answer is how high is the platform? And that equation, or the launch of the rocket, can be shown by this graph. This being the height of the platform it's being launched off of, rising, falling, and landing. So the height of the platform is modeled as x. So to solve, we just plug 0 in for the x's, which would look like now we solve this to find the height of the platform. Find out the platform is 100 meters high. So we can put that on our graph, on our parabola, as 100, which is where the rocket is starting its launch. The next question we want to answer is how long after the launch is max height? Maximum height on the parabola is the vertex. So using the vertex form, we are trying to find the maximum height. Knowing this, this side of the equation, h of x, is the height. So when we are trying to solve for the maximum height, we want to have highest possible number on the right side. Knowing that, when we are solving for negative 5 parentheses x minus 4 squared, we will never get a positive number. It will always be 0 or negative. So to get the highest possible number for this part of the equation, we set x as 4 to make sure that this side is 0 to add to 180 to get the maximum height. So the maximum height after solving will be 180 because 0 is the highest possible number we can get out of this part of the equation. So with the maximum height right over here at 180, go down and x is equal to 4, so 4 would be right there. So that is the vertex and the maximum height. So after 4 seconds, x is equal to 4. After 4 seconds, the rocket reaches its maximum height. The last question we're trying to find is when the rocket reaches the ground, or 0. So we are trying to find when the rocket hits the ground. So we want to put h of x equal to 0, which can also be written as negative 5 parentheses x to the 4, or x minus 4 to the squared plus 180 equals 0. So when we solve that out using algebra, subtracting, moving 180 over, dividing by negative 5 from each side, we get two answers. Could be x minus 4 equals 6, or x minus 4 equals negative 6. And the two answers we get are x equals 10 and x equals negative 2. The only answer that would make sense for this question would be x equals 10, because we cannot have the rocket land at negative 2 over here, because it cannot go backwards. So the answer we use for when the rocket lands would be 10 seconds after. In this video, we found the height of the platform, how long it took for the rocket to reach max height, and when the rocket hit the ground, all by using the vertex form of the quadratic equation and modeling it on a parabola.